And I also assigned some questions, all right, to some people. All right, I received a few. So that means I suppose the one that I did not receive the solution, I suppose those students would like to share, all right, themselves, okay, this morning on their own screen. All right, okay. Again, this is about chapter 3, okay, on the applications of trigonometry. Just to recap, all right, just to recap whatever that you have learned for this chapter. Okay, it is about solving oblique triangles, okay, using certain laws, all right. In this case, what we have is using a law of sines and law of cosines. And solving these oblique triangles, we are going to encounter 4 different cases or 4 different types of oblique triangles. Okay, in which you have like the first case is where you have an oblique triangles or triangles where perhaps 2 angles are given and one side are given. Okay, so you have like 2 angles and one side are given. So if you are given that type of case, that means you have another 1 more angles to find. Or if you have another case where you are given 1 angle and 2 sides, okay, and that angle is not included angle. Okay, so for that case, all right, and the previous case I mentioned, you are going to solve using what we call law of sine. Okay, so law of sine is quite straightforward. Okay, in the sense that when you establish your law of sine, all right, you have like in the form of sine A over A equals sine B over B. Or you can say A over sine A equals B over sine B. Okay, so that is law of sine. And then the third case where you may encounter a triangle in which similar to case number 1, all right, which 1 angle and 2 sides are given. However, that angle is what we call included angle, angle in the middle between the 2 sides. Okay, so if that's the case, then to solve that type of triangle, we are to use what we call law of cosine, as well as the last case, the fourth case, is where you are given a triangle in which all sides are given. So when all sides are given, also you are going to apply law of cosines to find angles, okay, missing angles. Okay, so you have those 4 different cases or 4 different types of oblique triangles which require you to use law of sine or law of cosine to solve. Okay, and you also being introduced, all right, about the area, formula area of another triangle or oblique triangles, which where you have like 3 sides are given. Okay, so to find the area is where we use what we call the Heron's formula, as well as another formula for the triangle where you are given 2 sides and 1 included angles. So to find area, you have also another formula to apply, which is what we call the half times AB sine C. Okay, that type of formula for area, instead of your basic formula for the area of a triangle, which is half times base times height. Okay, all right. Then you have also at the end of your chapter, you are given some application questions, all right, a real life application problems. Now, in this textbook, I noticed that for chapter exercises, actually there are many, okay, you are given many application questions. Okay, so if we have time, all right, if we have time, and if people actually can do the questions, maybe we can try to discuss all. Okay, we will try that. Okay, maybe for today, perhaps I'm going to just discuss questions from section 1, okay, until perhaps section 4, which is about area of a triangles. Okay, and for the last section, which is the real application, maybe we can save that for next week. Okay, however, if let's say we have time today, we can also look at perhaps one or two application questions. Okay, all right. I have okay. Let's if you have the book with you, okay. If you have the book with you, okay. If you can just turn on page um, this is for section 3.1. Okay, on page 104. Okay, on page 104. If you can all turn on page 104. This is exercise 3.1. Okay, I did not assign this question. Okay, I assigned the question starting from actually section 4, which is on the area. Okay, so this exercise 3.1 I did not assign. Okay, because I believe that you will be able to do this. Okay, all right, so you will be able to do this. Okay, so if you look at that question, anybody thinks that they cannot do or they need explanation? Because I'm not going to actually discuss this because I believe this one you can do. Okay, this is where you are given two angles and one side. Okay, so this is using law of sine, which you just need to find another angle. So very straightforward to find another angle when you are given two angles in a triangle. To find another angle, quite straightforward. Just subtract by 180 degrees. Then to find the next two sides, you just need to use law of sine. Okay, so this one I did not assign. So I believe that you should not have any problem for this. Okay, so if you have problem, you just let me know. If you need explanation, all right, so please let me know. If not, then I assume that you know how to actually do this. Okay, all right, then the next exercise is exercise 3.2. Okay, exercise 3.2 on page 109. Okay, on page 109. Okay, if everybody can see this. All right, this is also using law of sine. Okay, and you are given like exercise 3.2 is where question 1 you are given two sides and one angle. Okay, question 2 also two sides and no three, this is three sides. Okay, and see, and then okay, this is 3.2. So this 3.2 basically this is where you are given what we call um, one included angle. Okay, two sides and one included angle, as well as you are given three sides. Okay, like question number 2. So this one also I think this is also like quite straightforward. Okay, using law of cosines. Okay, so again I'm not going to discuss this today. All right, or this session I'm not going to discuss because I think that you can actually try this on your own and get the right answer. All right, okay, but if you have question, you just let me know. Anybody got questions on that? Okay, so what we are going to discuss is actually is on exercise, no sorry, exercise 3.3. Okay, I think I assigned, let me just check again. um yeah, okay, I assigned starting from exercise 3.3. Okay, so exercise 3.3 on page 111. Okay, so this question, all right, is all about area. Okay, so this question I assigned to Hazim. All right, so I got the answer from him, so let me just share it with you. Let us look at this solution together. All right. Okay, I hope everybody can see this. Okay, this part is question 1. Okay, so let us look at question 1. Okay, if you look at this question 1, you are given that triangle. All right. So you are asked to find what is the area of the triangle. All right. I hope you all can see this. Okay. So basically, if you look at this question, all right, your friend separate the given triangle into 2 triangles. All right. So this is the given. All right. This is the given triangles in the question. So your friend separate these 2 triangles. So one is the big one here, and then the smaller one. Okay. So basically, all right, so your friend find the area for this using this formula, which is this is the formula, a basic formula of a triangle for any like right angle triangle. So you can find using what we call the half times base times height. Okay, so if you do that, half times base times height, all right, for this one you get 28. This is for the smaller, sorry, the bigger triangle. All right, as well as then the smaller triangle, also your friends are using, okay, half times base times height. All right, and then compute that, and then your friend just add these 2, all right, which is then 38.5. Okay, this one is correct. All right, you can do this, like you can separate straight away. All right, okay, you can actually, or people, does anyone got any different answer, or does anyone got any different way of doing? Anyone? Okay, anybody? This one is actually correct. Okay, so that means you just separate, then you got the answer. You just add. That means you just find area of the bigger triangle plus area of smaller triangle. So you add these 2, you got your answer for the area. Is there any other way of doing this? Anyone? Anybody? Anybody got any different way of doing, or anybody would like to ask question? Okay, another way of doing. A shortcut, not a shortcut. Less method or less working. Okay, this triangle, if you look at this triangle, okay, the height of the triangle is given here. This is the height of a triangle. In fact, this is the height of a triangle for both triangle, the bigger triangle and the smaller triangle. This is the height for this triangle. Okay, either you say the height for the bigger, the whole triangle, or you can say this is the height for this triangle as well as height for this triangle. So this is actually is the height. So if that's the case, all right, you can just straight away, all right, find the area by using also the half times base times height. Okay, this one is, you can use half times base times height because you are given the height. Okay, the height of the triangle is given. Okay, base straight away, you can just, oops, you can just add the whole length. That's the base. Okay, for the big, for the whole triangle, that's the base. That means it's 11, isn't it? Times height is 7. Okay, so you get 38.5 as well. Okay, unit square. because this is area, so unit square. Okay, so that's actually is the area. Okay, so either you use like this straight away, or you can also do separately. It's up to you. It's fine. Again, as I mentioned, at the end of the day, during exam or even during test or even during, all right, your working, it's all based on your own understanding, how you look at the question. Okay, based on your understanding. So it doesn't matter how you do it, as long as it is logic and it's correct. Okay, all right. Okay, so that is question 1. Then let's look at question 2. So if you have question, you just ask. Okay, this is question 2 now. So what is the area of the triangle ABC? So you are given this type of a diagram. Okay, so this diagram, you have this is a right angle triangle there. All right. Okay, 5.8. So that is 5.8. I hope you can see from the sketch here, or you can refer to your book for the diagram. Okay, so you have that height there is 5.8, and then you have 1.5, and then from B to C is given 6. A to B also, length AB from the diagram is 6, and then length AC is given as 9. Okay, so find area of a triangle. Okay. All right. Okay. Okay. Anybody got different question than this? Different answer. Sorry.
Dem tu C plus 1.5 ke apa?
Sorry. Say again.
Equal C plus 1.5 eh?
Yeah. Your friend. This one. You mean this one? Yeah. B equals 6 plus 1.5. So basically, I think your friend actually wrongly add, right? So the base is actually is the whole length here, which is correct. 1.5 plus 6. 6 plus 1.5 is correct. But it's wrongly adding this. So it should be 7.5, isn't it? Okay. All right. So that means this is actually supposed to be 7.5. So calculate one more time. Anybody? What's the answer? Can someone compute this again?
That one is 87 over 4.
Say again?
87 over 4.
87 over 4. Or in terms of decimal?
21.75.
21?
21.75.
Yeah, 21.75.
21.7.
But I haven't finished right the step.
Sorry?
I haven't finished right there. That one is not the final answer, right?
Yeah. Okay. So what do you
Have
get?
to minus.
Because the question, this is the area of the whole triangle, right?
Yeah.
Okay, this is the area of the whole, the one big triangle, all right? But what you want is to find the area of triangle ABC, okay? So that means you want to find also area of just this smaller triangle, okay? So if you find this smaller triangle, okay, so then, all right, that means this is actually not the area of ABC. This is just area of big big triangle. You can say big triangle. All right. And then area of, or you can do like this, huh? Or you can do like this. Maybe we'll do this like this. You can say area of ABC equals, all right, you have your this one, which is your half times base, which is your 7.5. This is the one that is for the big one, okay, times 5.8, and then minus half times the base, which is the smaller one, 1.5 times 5.8. So straight away, then only you get your angle. Oh, sorry, that's only you get your area of a triangle ABC. Okay, so can someone compute that? How much do you get?
17.4.
17.4. Okay, unit square. So you got to subtract, okay, the bigger one and the smaller one. So you get your area ABC. All right. Okay, so that is question 2. Okay, let's look at question 3. Okay, so this time the area of the triangle is given as 42 units square. What is the height of the triangle? Okay, so basically you are using the same thing. All right, area equals to half times base times height. Okay, then this is given 42. All right, and then base is given. So what you want is height. So just rearrange your equation. So you get your height. Okay. All right. Any question for this exercise? Okay, then the next one. See. Okay, Syakir Aiman Arifin. Okay, I also got this one yesterday for exercise 3.4. Let me just, but I haven't actually placed this. Okay, hold on. Oops. Okay, this one. Okay, this is exercise 3.4 on page 113. Okay, question number 3. Okay, now if you look at your book for question 1 and 2, I think that 1 and 2 is quite straightforward. All right, you are given all the length for the triangles, all the 3 lengths, the 3 sides, okay, and then you have to use Heron's formula to find area. So question 1 and 2 basically straightforward. So I'm not going to discuss that. Okay, but if you have question, you please let us know. Okay, but I'll start with question 3 here. Okay, the side of a triangle are 5y, 6y, and 9y. Find an expression for its area A. So basically, this one also is same as question 1 and 2. It's just that this question 3, all right, the length are given in terms of expression, not just one real number like question 1 and 2, but you are given in terms of expression like 5y, 6y, 9y, okay, with the y, okay, with the variable. Okay, basically it is actually just the same as like question 1 and 2, like your normal, all right, using Heron's formula to find area. Okay, it's just that question is asking you to find area in terms of expression. Expression means because of there's a variable y here. Okay, so basically, all right, this is what you need to do. All right, first you need to know the Heron's formula. So that is where you have to compute. You got to compute the S first. So S basically is A plus B plus C over 2. It's the sum of all the three sides divided by 2. Okay, so if you look at this one, this is correct. Okay, where you just add, all right, 5y. Okay, 5y plus 9y plus 6y. All right, so you do that. So you got 10y. That is your S. Okay, so that is your S, which is 10y here. I hope you can see this. Okay, this is S. Okay, that is S, 10y. Okay, and then to find area, just substitute into the formula. So Heron's formula, you have a square root of S and then times S minus A times S minus B times S minus C. Okay, so what you need to do, you just do like this. Okay, so you have S and then you have your S minus A, S minus B, S minus C. Okay, so that is correct. Okay, then it's just a matter of simplifying. Okay, this one actually not complete. Okay, Syakir Aiman, this is Syakir Aiman Arifin.
Ya, dia.
Okay, all right. So because we got two Syakir Aiman, isn't it? Yeah, this is Syakir Aiman Arifin. Okay, you just need to simplify. Okay, this is like not complete yet. So you just need to simplify. You just multiply the whole thing, 10. All right, you multiply this. 10 times 5y times this times this. So do that. So if you do that, what do you get in the square root? Syakir Aiman Arifin, are you there?
Yes, kejap.
Okay. Compute that. What do you get?
Madam,
Okay, what? Yes, okay.
200.
Okay, 200 y what? Y
Y
power?
power 4.
Yes, y power of 4. Okay, but then you just need to simplify. Just one more step, perhaps you can just simplify. Okay, 200 square root of 200 basically is the square root of 100 times 2, right? So square root 100
Yes.
is 10. So you can say 10 square root of 2 and then
2.
y power 4. Y power 4 is y square, isn't it?
Yes.
So it is the same as just to write this as 10 square root of 2 and then y power 2. So your answer is in terms of this expression. Okay? All right. Any question? Or you yourself got question, Syakir? This one okay?
Okay, madam.
All right. Okay. Then the next one. Question 4. Okay. Oops. Not this one. Okay. Question 4. Okay. I'm not sure whether people can see this. This is question 4. Okay. This time, the sides of a triangle are x plus 1, and 2x minus 1, and its area is x times square root of 10. What is the value of x? Okay, again, every time all the three sides are given. Okay, no angle is given. All the three sides, only the sides are given. And question is talking about area. Definitely, it has to be Heron's formula. Okay, the formula just now that you compute the S, sum of 3 side divide by 2, and then the formula area is that square root just now times s minus a, s minus b, etc. So that is Heron's formula. So definitely this one also will be related to using Heron's formula. Okay, so area is given as x times square root of 10. That is the formula area. That is the area of a triangle. So you just need to use the same, all right, the same thing like just now, except for this time the area is given. Okay, so definitely you still need to find your s. All right, you still need to find your s. So I can't see your s here. Okay, let us do this. All right, so basically the three sides are, doesn't matter, I just write these are the three sides. These are the three sides. You are given x plus 1, and then 2x minus 1. This is the three sides given. Okay, the length of three sides. And you are given area from the question is given as x times square root of 10. So what is the value of x? So this is what you want to find. Okay. All right. So again, because it's about the three sides and area, so by using the Heron's formula, you need to find out first what is the s. So s is actually is the sum of the three sides. So x plus 1 plus, all right, 2x minus 1 over 2. This is formula for the s. So you just need to open up the bracket, all right? So then if you open up the bracket, you will get your s equals to, okay, so you got 4x then, and then you have plus 1 and minus 1 cancel. So that means 4x over 2, or in other words, you get your 2x here. This is your s. All right, so then you have a formula area using Heron's formula. All right, where you have your s times s minus a times s minus b times s minus c. So just do the same thing. So s times s minus x first, then s minus x plus 1 times s minus 2x minus 1. Okay, area is given as x square root of 10. So what you need to do, you just need to simplify, all right, your expression inside. Okay, all right. So what you have is what? You just need to, maybe you just need to simplify. So you have your, this is 2x minus x is just 1x, and then 2x minus x plus 1. So you still have 1x there, x minus 1 here. And then you have your positive 1, isn't it? Okay. Now, how do I get rid of the square root? Get rid of the square root by squaring both sides. Okay. So that means now I have on my left hand side is 10x squared. On my right hand side, okay, on my right hand side, I just need to expand that. So if I expand that, all right, I will get on my right hand side is what? 2x cubed. Okay, and then minus 2x cubed minus 2x squared, x cubed minus 2x, isn't it? Okay, minus 2x squared, isn't it? Okay, and then I'll just bring everything on one side maybe. So 2x cubed, then I have my minus 12x squared, isn't it?
I know.
Okay, All right, so that means I am solving this equation. Okay, now remember, we can just factor. I'll take out 2x squared. All right, then I have my x minus 6. So then my solution will be x equal 0 or x equal 6, isn't it? Okay, or you want me to write like step by step in case you don't understand. Okay, that means 2x squared equals 0 or x minus 6 equals 0. So x equals 0 or x equal 6. Now, because we square from the beginning, this one, okay, to get rid of the square root, we square. So that means we do something about the original equation. And if you recall what I mentioned last time, every time you are dealing with the equation with the square root, you square. So your final answer, you must always check. You must always check by substitute your value here, x equals 0, x equals 6 into the equation. Okay, what equation? It's actually the equation without the square. Definitely is the original equation. This equation, the area which is you need to check, substitute. This is what you need to do. Substitute x equals 0 and x equals 6 into, okay, you substitute into this equation, the one which is the x square root of 10, whether equals to the one, the 2x minus x just now, okay, or not. All right, this one, the 2, or maybe you can just use the one that you have already simplified. Okay, because basically you can just simplify the one here, 2x x minus 1. Oops. The one that 2x, and then you have your x minus 1. This one, much easier. Okay, so which one do you think is the solution? Which one do you think is the solution? Can you quickly check using your calculator? Are both solution? Okay, from the chat. Okay, 6. Yes, solution is only one, isn't it? Which is 6. Okay, I hope you have already computed the 6. Okay, substitute. You'll see left hand side, right hand side, because straight away I'm looking this 0. If I look at the 0 here, straight away I know that it is going to be what?
0.
0. Okay. All right. Okay, so I hope you already checked. So this is what you need to check. All right. Okay, that is this question. I think the next one. Okay, the next one I did not receive. This is the next one is Shakir Aiman Muhammad Shah.
Thank you, madam.
Okay, welcome. Okay, thank you for sending me the solution. Okay, Shakir Aiman Muhammad Shah, another Shakir. Shakir Aiman, are you there? Shakir Aiman Muhammad Shah. Not joining in the meeting. I don't see another Shakir here.
Maybe if this question 4 I do in other method can not?
Okay, what method you use?
And the one that you square both sides, right? And
Okay.
I did not square the both sides. I just expand the right hand side, the 2x times x minus 1 times 1. I expand it until the end, and I get that S sub 10 equals to S sub 2x minus 2. And then I use the 10 equals to 2x minus 2.
10 equals to
2x minus 2. I
2x
expand it.
minus 2.
I expand the right hand side inside the square root.
Oh, which means you have until this one is still the same.
X square root 10. Yep.
You still have this, right?
Yeah.
And then you expand this on the right, the right hand side.
Yeah.
2x square, so you get your 2x cube, right? Minus 2x square.
Yes.
This is
And
10
then the
square
left hand side is x square root 10, not 10 square x.
Oh, you got x square. Oh, sorry.
The question.
Yeah. Okay, sorry. Did I write correctly just now?
Yes.
Huh? Yes.
Yes.
It's x square root 10, isn't it? X square root
Yeah.
10. Okay. And then what did you do?
I factorize the x go out to the at the right hand side, right? I factorize x square. That means
Oh,
x sub
okay.
10 equals to x square.
Oh, square root? What about the square root?
X square. Yeah, inside x square.
Oh, okay. X square,
Then 2x minus 2.
2x minus 2 like this.
Yeah. And then the x square go up again x, right?
Oh, okay. And then you put like this.
Yes. 2x minus 2. Then I use the 10 equals to x minus 2 can, right? Then I use the
Oh,
method.
okay. So that means you cancel
Yeah.
Okay, so when you cancel, okay, remember last time when we cancel the x, that's when we are going to lose like one root, isn't it?
Mm.
Even though that may not be the solution, okay? Because then you do like this. Then only you square both sides.
Yeah.
Then only you square both sides, so then it becomes like this.
Yes.
Then you got your x equals 6.
Yes.
Okay, so you got like one root here, isn't it?
Yeah.
So if we solve like just now, we will get x equals 0 and x equals 6, isn't it?
Mm-hmm.
But we need to still substitute, isn't it? And check. Okay. So just now, if we look at this one, how many solution we got? Have you all checked?
2.
Right. So 2, isn't it? So but here you only get
1.
1. So that means you lose your one root, isn't it?
Mm-hmm.
Right. Okay. You lose your one root.
Alright, madam.
Okay, so it's like partial, isn't it?
Yeah.
Not to say partial lah. I mean, at the end, it's like 1 mark. You will be losing like 1 more mark, like something like that.
Okay, madam.
Still can be done. Okay, it's just that along the way, because you cancel. The thing is, whenever we solve any equation, don't cancel variable. You cancel numbers, okay, but not the variable.
Alright,
Variable
madam.
cannot be cancelled along the way because variable, it might have value. Okay. So you cannot cancel the variable. You can cancel number, but not the variable. Variable, you have to solve it until the end. Okay?
Madam.
All right? Okay. So Shakir Aiman Shah, not here today. All right, let us look at his question. The one that I assigned. Exercise page 117. Okay, actually that's a typo, isn't it? 117, it's not exercise 3.4, it's supposed to be 3.5. So because we already got 3.4 at page 111, so page 113, so 117 is supposed to be exercise 3.5, but I think it's a typo. They put it 3.4 as well. Okay, let us look at this question 2 and 3. Okay, question 1, I think that one is straightforward. Question 1. Okay, let us do this together, perhaps. All right. Okay, look at question. This is exercise. Supposed to be exercise 3.5, not 3.4. This is page 117. Okay, if we look at this one, question 1 I did not assign because I think question 1 is quite straightforward, because you are given two side and one included angle. Okay, so remember when we have two side and one included angle, question asks us about the area. So question 1, you can straight away use your formula, the half AB sine C. That is question 1. Question 1, you just use your formula half AB sine C, or half AB, half BC sine A, or half like that, right? Half AC sine B. That is the area for a triangle where two side and one include angle are given. So that is the formula area that you use. Okay, so that is question 1. So straightforward. Okay, so question 1 straightforward. Half times 13 times 8 times sine 85 degrees. So that is question 1. Okay, let's look at question 2. So now given, okay, if you look at the diagram, so everybody, you refer to the question in the book. Okay, so you are given a diagram. Okay, so that is a parallel, what we call it, parallelogram. Okay, parallelogram. All right, the diagram consists of parallelogram made up of a pattern of congruent triangles. Okay, congruent triangles. What do we mean by congruent triangles? What is the area of the parallelogram? Congruent triangles. Congruent, in Malay we call it what? Segitiga. Is it sebentuk? That is what we call congruent triangles. Okay. So what is the area of the parallelogram? Okay. So look at the diagram given. So how do we find area of a parallelogram? By the way, what do we mean by a parallelogram made up of a pattern of congruent triangles? What does it mean? It means if you have, for example, a parallelogram, this is parallelogram. Okay, this is parallelogram. Okay, if this is our parallelogram, and it mentioned that it made up from, okay, made up of congruent triangle. So if this is one parallelogram, so that means if I divide by half like this, okay, sorry, I cannot draw a straight line. So that means this angle and this angle are congruent, sebentuk, is the same. All right, they are actually the same. Okay, both triangle are the same. This is what it means. Okay, so how do we find area of a parallelogram? How do we find area of a parallelogram? Anyone? Okay, if you look at the diagram there, okay, either I draw like this or diagram in the book is given like this, like that, like that. Okay, so basically it's the same thing. All right, so let's say I just put this number here. What you are given, maybe I can just write this as like this is 6 feet, and then this is 12 feet, and then you are given angle here. That angle is 118. Okay, 118. So how do we find area of a parallelogram? If we talk about area of a triangle, we are talking about this, that triangle, half. So that means triangle actually, area of triangle is actually is half of the area of a parallelogram. Okay, area of a triangle is actually is half of the area of a parallelogram. So if I say area of a triangle equals to half of area of a parallelogram, That means area of a parallelogram equals 2, right, times area of a triangle. This is what it means, right? So you can see from the diagram, parallelogram consists of two triangles. Okay, parallelogram consists of two triangles. Okay, so basically this is actually is the formula area of a parallelogram. You're going to see this area of a parallelogram again in chapter 5, last chapter. Okay, when we talk about vector, we will again talk about area of a parallelogram. All right, and you are again using the concept of twice of the area of a triangle. Okay, all right, okay. So in this case, if you look at the given diagram, all right, if you look at the given diagram, so basically you can just use what? You can just use how to find this? How to find this, by the way? Anyone? So how to find question 2? This is area of a parallelogram. Okay, so don't get confused, eh? You can also look at parallelogram like this, eh? I can also draw parallelogram beside like this one, like this. Or we can also have like our triangle, we can cut like this, eh? Also the same. Okay, I can cut my triangle like this for a parallelogram, or you can say that you can cut your triangle like this. Okay, you can also cut your triangle like this. So it is still true, okay, that area of a triangle is half of area of a parallelogram. Okay. Okay, area of a parallelogram, that means area of a parallelogram is twice the area of a triangle. Okay, so you can just straight away, therefore area of a parallelogram from here is 2 times area of a triangle. In this case, you can just use your half that formula, because this is again side angle side, side angle side. So you can just use your half, the one half AB sine C, that type of formula. This type of formula, because you know the angle here. This is what we call the included angle. Side angle side. Okay? Alright. So then just straight away you compute for this type of formula. That means 2 times half is 1, isn't it? Okay, never mind. I'll just write it again. 2 times half times AB. A just now is from the diagram 6. Another length is 12. And then the angle given is 118. Okay, can you compute that one? What do you get?
63.57.
3.6.
Say again?
63.6 feet square.
63.6
6
or 63
feet
point,
square.
just now I heard 57 or 63.6. Okay? Unit square. All right. Okay, so this is like the whole parallelogram. Okay, one whole parallelogram. Okay. All right. Okay, I think another one just now is question 3. Okay, we can take a break since Aiman Shah is not here. I also assign him another question 3. So if you, while taking a break, can you all look at question 3? There's another diagram here, area of the field. Okay, area of the field for question 3. So perhaps we can take a break for 5 minutes. Okay, so perhaps you can all look at that question as well. Okay. Okay, everyone. Have you tried that question 3?
Madam,
Okay, all right. Anybody would like to share the answer for question 3?
is it 20? You mean the working or the answer?
The working, perhaps. Or what's the answer?
The answer is 223,871.5 feet square.
Point?
0.5.
0.5. You got 0.5. Okay. Anybody else got any different answer? So you got this is question 3. So area is just now you say 223,871.5. Anybody else got
Madam.
any different answer? Anyone? Same. All right. Okay. So no different. So is it all understood? Okay, same answer. All right. Okay, so I can see from the chat, same answer. All right. Okay. Same, Saran. Okay, so that means everybody understood how to do this. Okay? So can we proceed? So then we don't have to discuss. I'm sure you know how to do this. All right? So basically, you just find the area of the two, right? Two triangles. So you have your triangle ABC as well as triangle ADC. And you are given two sides and one included angle. So you just use formula half AB sine C, something like that. Okay? And then you add both, eh? So, okay. Next one. Let me see. Exercise chapter 3, page 126. Okay, page 126. So this is the chapter exercise at the end of the chapter. Okay, so I assign question 5 onwards. That means question 1, 2, 3, 4. I think you will be able to do this. Okay, based on my own judgment, looking at the question, I think you can do. You can do question like question 1. This one I think is a straightforward. Okay, question 2 also. Question 3, question 4. So I'll start with the question 5 actually. Okay, so I'll just look, because I just look at the diagram. So maybe looking at the diagram, perhaps, it is not like just straightforward triangle. So that's why then I start assign people question 5 yesterday. Okay, so I assign Akmal Azmi. Akmal, are you there for question 5? Akmal? Akmal Azmi? Akmal Azmi? Not there.
Ya, madam. Sudah WhatsApp dekat madam.
You just send me.
Ah,
Let me check. Okay. Okay, question. Okay, let's look at question 5 here. Okay, I hope everyone can see this. Okay, let me just. Okay, ABC. So you find. Oh, okay. So you have the whole stretch is B. All right. Okay. So the whole stretch is B. So using the law of cosine, so you got your B squared. Oh, okay. All right. Okay, so this is one method. All right. Okay. So this one looks okay. All right, because then you just find the whole stretch. You find the whole stretch of this length, the whole length here, and then you got when you apply law of cosine, you have a quadratic equation, and then you got two answer for B from the quadratic equation. One is positive, one is negative, but because B greater than 0, because B is the length, okay, length is positive, so we consider only positive number, not the negative number. All right, then only you subtract by 8.5 given from the question, so you got your EC, okay, 0.727. Okay, all right, this one can be done like this. Yeah, okay, this is logic, correct. Okay, I hope that is correct, the value value is correct. Okay, anybody got any different way of doing or any different answer? Everybody got the same answer here, 0.727 for EC. This is E here from the question. This is E. So EC. So you just need that length, EC, length of EC. Anybody got question here for this question 5? Okay, and then there's one more, isn't it? To the question. Length of EC and then angle AED if the area of a triangle AED is 54 centimeter squared. Do you have another answer? Okay. Anybody got question for this length EC? Okay, length EC. Do you got another answer for the angle? Muhammad Akmal? Akmal Azmi. Akmal Azmi. Oh, got two different. Akmal and Azmi also got. This is Akmal Azmi. Okay, this is Akmal Azmi. Akmal Azmi, do you have another answer for your angle? Or did you send me? Let me check. Did you send me two answers? B, you didn't get. Okay. All right. Okay. Uh, class, do you got this one? Okay, for EC. Okay, this is one way of doing. Right. Okay. I suppose if you got no question, that means you understood for this length EC. So how do we find? How do we find the second part for B? This is question 5. This is question 5A. Okay, for part B, you want to find what is length of AED if area AED is 54 centimeter square. Just look at your this triangle. Now, okay, let me just draw the triangle here. Triangle AED. Something like this. Something like this. This is A, E, D. This is 15 from the question, 15.6. And then this is AE is 8.5 centimeter. This is 15.6 centimeter. So you want this, right? And area is given as 54 centimeters squared. So again, this is also can be quite straightforward, isn't it? Side, angle, side. So this is included angle. So when it is included angle, area for this type of oblique triangle, you use the same formula just now, half AB sine C, something like that. So when you want to find area, you got to use that formula. That now area is given 54 centimeter squared. So you want to find that angle. So angle E, basically it's angle E. Okay, angle E. So that means you know that area. Okay, you know that area equals to this formula, this type of formula. With the included angle, you have something like this, for example. Okay, so from the question, this is given, this is given, this is what you want to find. So that means you just rearrange your expression or equation. Okay, or in other words, if you substitute everything from the given question, area is 54 given, half A, B, doesn't matter which one A, which one B. So 8.5 times 15.6, and then sine. Okay, this is sine. You can say angle, or maybe I can just write as angles E. Understood? Sine E, because that angle happened at that E, so we can just say angle E. Okay. All right. Okay. Can you compute for me? Okay. Can you all try this? What did you get? Okay. Can you all compute for me? What do you get for E? Okay. Yes, Sagi got 54.49 or 54.5. Okay, that is from the chat.
Yeah. 54.5 point.
Okay. Sorry? Got?
54.5.
Okay, you got this one using calculator, right? Or
Yes.
have you used one decimal? Okay, do you think it's logic? Look at the diagram. Because this is using sine inverse, isn't it? You're using, this is sine. Remember sine, you got to consider angle, because sine inverse, you got to consider angle, all right, in quadrant 1 and quadrant 2. Look at the diagram. Okay, so is it logic to have acute angle there? What you should do?
Maybe minus with the 180. We'll get the
Yes,
125.5.
yes, correct, Saran. Because sine, you got to consider, you can consider from angle 1 and angle 2. This is now, if you look at the diagram, it's obtuse angle. Angle which is more than 90 degrees. Okay, all right. So you just subtract. Okay, so therefore E actually is 180 degrees minus 54.5. What is it, Saran, just now? Okay,
1 to
125.
5.4.
Okay, 1 to 5.5. Okay, so that's the one. Okay, so because 54 is the one in quadrant 1. Looking at the diagram, it is an obtuse angle, so you just subtract by 180 degrees. Okay, so that is question 5. Okay, question 6. Okay, let me just check. Question 6, I think I got from Anik. Okay, hold on. Let me find the question, the answer. Okay, this one. Can everyone see this? Let's see. Let's see this. Okay, this is question 6. Not really clear, isn't it? I also cannot see this clearly. Okay, let us try. Try to look at this. Okay, A, B, C. A is 20. B is C is now B is not given. C is 16. Angle A 30 degrees. How many distinct triangles can be drawn? Given this measurement, explain why, then solve the triangles. Oh, okay, all right. So that means this is not the angle included. So that means this is two side. This is two side and one angle, but angle is not angle included. That means this is not law of cosine. This is going to be law of sine. So if it is law of sine, remember this is what we call the ambiguous case. So it can lead you to answer to solve actually either one triangle, two triangles, or none or no triangles. That's why the question say how many distinct triangles can be drawn, and then explain why. So how many, basically you can just say one, solve for one triangle or two triangles or no triangles. Okay, and then explain why, then solve the triangle. Explain why basically along the way, because when you remember, when you compute for the sine, all right, you need to consider for angle in quadrant 1 and angle in quadrant 2. Okay, so that's actually the reason. Okay, let us check this. Using the law of sine. Okay, so you try to find, you have, okay, definitely we have to find sine C first, because the opposite length of angle C is given 16. So therefore, we are using law of sine to find sine C. Okay, so sine C, you got 0.4. Okay, this is where you consider, this is 0.4. So you consider, okay, let me use my calculator as well. Let me check check the value as well. Okay, you all check also, Can you all try to do this one as well? Try to go over this solution, and then along the way maybe you double check the answer. Okay, so sine inverse 0.4. Okay, so you got 24. Okay, nearest degree. Okay, either 23.58 or 24 can. All right. So this is one okay. All right. So another angle that you need to consider. Okay, so the one that is given is 30, isn't it? So that means okay, so another angle. Okay, so this is C1. This is C1. Okay, angle in quadrant 1, 23.58. Okay, another angle is in quadrant 2. This is quadrant 1. Okay, check for angle in quadrant 2. So 180 minus 23.58. So it's 156.542. This is quadrant 2. Okay, whether we consider C2 or not, then we said try at 156, add with the given angle from the question. The given angle is 30 degrees, right? Okay, obviously this is actually is greater than 180. Okay, so that means you don't consider this. The only triangle or the only angle for C is actually is 23.58, or if you want to round to the nearest degree also can, 24 degrees. Okay, so 24 degrees or 23.58 doesn't matter. So that means for this question, that means you are solving for just one triangle. Okay, so this is where you need to show you got to show this, because this is actually is part of the reason why. Explain why, then solve the triangle. This is the answer for that explanation. Okay, basically this is the answer for that explanation. Okay, the explanation why, then solve the triangle. So this is the one that you have to show. All right, so that means you can say like that. That means, all right, only solve only one triangle. You can say like that. Okay, so then only you find your B. All right, so I suppose this is correct. So that one, all right. So then 180 minus 30 minus 23.58. Okay, so that is correct. B. So then you find the other length, I suppose. Okay, I suppose that one is also correct. Okay, so I assume this one correct, because looking at this is the law of cosine. Okay, I hope people double check this, because this is correct. The to find you need to find. Oh, you use law of cosine. You can also use law of sine, isn't it? Okay, because the fact that you know the angles, all right, you know all these angles. The fact that now angles, all three angles are known, and you already have two sides, so you just need another one side. So you can also use law of sine, but you can also use law of cosine. So it doesn't matter which one. So I want people to double check this, people to double check length of B. Okay, everyone. Can you all check quickly? B, do you get the same answer with your friend here? Maybe you can use a law of sine. You check with law of sine. Your friends use law of cosine. You do with law of sine. You see whether you got the same answer or not. 32.2. Okay, he did. Yes. All right. Okay. So then this is correct. Okay. So either you use law of sine or law of cosine. So either one will give you the same answer. Okay, so when you solve for ambiguous case, make sure you have this. This step is a must because you will get some marks here because this is actually is the important step also. This is basically to answer the question in the book, say explain why. Okay. All right. Okay. So this is question 6, and then next question. Um, Amirul Arif. You send me, eh? Is it Amirul Arif? Let me check. Amirul Arif. No, I don't have. Amirul Arif, are you there? Okay. Amirul Arif? Amirul Arif. Question 7. Amirul Arif, are you there? No? Amirul Arif, you're not there? Okay. The rest of you, can we all look at question 7? Okay, question 7. Next is question 7. Question 7. Okay, let's look at question 7, everyone. In a triangle ABC, all right, A is given 7, C is 16, and angle A is 30. How many distinct triangles can be drawn given this measurement? Explain why, then solve the triangle. Okay, again, this is also ambiguous case, all right, because how do I tell whether this is ambiguous case or not? By looking at the question, you are given two sides and one angle, and that angle is not included angle because side A, small a is given, and then angle A, big A is given. So definitely that angle is not included. If it is included angle, you should be notice something like this. The two side given, for example, A, small a, and small c, and then the angle given is the B. Okay. All right. That is actually is included angle like this one because A and A. So this is not included. This is actually is the ambiguous case. That's why question say how many distinct triangle. This is like just a previous question, and then explain why, then solve. So this is ambiguous case. All right. Okay. So since I don't have the solution with me from your friend Amirul Arif, can everyone quickly try this? Maybe in 1 minute. I think this one should not take long. Because ambiguous case, definitely like something like this, you are definitely going to find angle C because length C is given. So angle C is the first step that you are going to find. So can you see what do you get for the C for the angle quickly? And if somebody has tried this, you got the answer, you just share your answer. I mean, you just shout your answer. Tell me how many triangles. Okay, while you are solving for 7, Let me just get an okay. The last question I got from your friend here, Fazari. Fazari sent in question 8. Let me share. Let me just. Okay, question 7. Okay, let me see the okay, from the chat. No triangle exists. None. No solution. Okay, everybody got that one? You got the same thing? Okay. So no triangle exists. No triangle exists. This is answer from the chat. No triangle exists. Okay. None means no solution. No solution. Okay. All right. So why does no triangle exist? Because definitely, I suppose when you compute for your sine c, your sine c is 1 point something. Okay, the value is bigger than 1, in which it is go beyond 1. The range of sine is between 1 and -1. So value for sine cannot be go beyond 1. So in this case, for this question, I suppose when you can compute, you will get more than 1. So that means no triangle exists. Okay. All right, no triangle exists for this problem, or information from this measurement from the question or something like that. So no solution. All right. Okay. All right. I hope so far so good. Then we move on to the last one for today, okay, which is question 8. Okay, this is from Fazari. Okay, let us see this question. In triangle ABC, A equals 10, B equals 16, and angle A equals 30. How 30 degrees? How many distinct triangles can be drawn given this measurement? Explain why. Okay, again, this is similar, ambiguous case. All right, the way we can tell is from the question itself. Even though diagram is not given, you can tell this. Two sides are given and one angle is given, and the letter you see a small a given and big A is given. So that means that a big A, the angle is not included. So this is actually is law of sine, where all right, it is an ambiguous case. So again, in this case, you are going to find first, you are going to find sine B first, because the one that is given is B. Small b is given. That means angle B is the first step. Okay. Let us see your friends working here. All right. So again, yeah, this is the one, sine B. Okay. You are going to compute for sine B first. Okay. So you are going to compute for sine B first. All right. So this is what you need to consider. I suppose this is correct. Okay. People can double check this. All right, so you consider if your one angle from the question is 53.13, then you consider another one, all right, which is 180 minus 53. So you got this, okay, angle, all right, okay. So this is what you have to show, okay. So you consider, all right, and then of course, because this 127, all right, 127 degrees, you add with the given from the question, still less than 180. Two triangles. Okay, both. All right, or B1. So another one is B2. Okay, so you consider both. All right, so then you just solve one by one to get your C. Okay, to get your Okay, let me see. Where's your angle? You don't need to, okay, Fazari. Once you have gotten your B, the next angle C, you can just subtract by 180 degrees. Or is it your C here is, oh, okay. The one that is given from here is your small c, okay. Oh, so you just show from the diagram, eh? Okay, so you have to write, eh? Or you just do like what I taught you in class, perhaps one by one, step by step. Triangle 1 first, and then triangle 2. So triangle 1 means with this value B, that is triangle 1. So you get your C1, this is B1. That's how we do, isn't it? All right, so get your, okay, looking at yours, triangle 1. Okay, first of all, from the question, you just follow whatever that is given. Okay, A is 10, B is 16, and angle A is 30 degrees. Okay, so triangle 1. So you got your B, 53.13. Okay, so your B is 53.13. So you got this. Then you compute for your C, 180 degrees. Okay, minus 53.13 minus the given 30 degrees. So you got your angle C. Then only your small c using the law of sine. Okay, so using the law of sine, so you got your small c. This is using law of sine. Then triangle 2. So do step by step like this. That will be much easier for me to see and to mark. Okay, during exam or during test or whatever, during assignment. Also similar, this is B1, so you just use the subscript. Then B2, all right, from just now, your 127, okay, 127. Then your C2, so 180 degrees minus 127 minus 30, so get another one. And then C2, using law of sine. So you do step by step like this. That will be much easier for me to see and to mark. Okay, so that I don't have to like try to find. Okay, find your answer. Okay, even though actually philosophically when we mark the when we mark assignment or we mark test or final exam, we are not actually penalizing you. We are trying to find answers from whatever that you have written. We are trying to give you more marks actually. Okay, that is actually the spirit, the spirit when we mark. We are trying to actually find what more marks that we can give you. Try to find what are you trying to do here. Try to figure out, because we do not want to penalize you. But if let's say, this is actually is true for every lecturers, but if let's say you write like you mixed up everything, it's like jumbled up here and there, and we cannot actually find. And after a while, we are like exhausted. So then that's when we just like mark you like wrong because we can't see. That is actually dangerous. Okay, dangerous, because you know what, we are all human beings. So after we mark so many and still we cannot see clearly what people are trying to do. So that is actually the danger part. Okay, because we are human beings. So when you write properly, step by step. Okay, write properly, step by step. Just so happen this time because it is online, online test, online exam, that's when you have to use your own paper. All right, but if you are doing it on campus, face to face, all right, you are given a script. So I will always tell students, don't worry, ask for more script. You can use like 2, 3, 5 script if you want. Okay, just make sure you write clearly. Don't try to like save papers during exam or even during test. But now because it's your own, so then it's difficult for me to say something like that. Okay, but you know, if you are here with our scripts, right, our answer script, I will always tell students, you know, ask for more scripts. All right, don't be so stingy when you write. Write clearly. Okay, write in a bigger font. Okay, don't write like small. No, I'm getting old, so I cannot like, you know, see something that which, you know, very small, you know, handwriting. Okay, so all that actually does matter. Okay, when we mark, so you must make sure, as I said, step by step. All right, make sure that I always tell students, you don't assume I understand. You assume I do not understand, so you are trying to make me understand what you are trying to write. Okay. Okay, I think for this week's session, all right, we discussed until this question 8. And if you look at books, all right, your module. Okay, starting from question 9 onwards, 9 until 33. Okay, question 9 until question 33. These are all applications. These are all real application problems. All right, so perhaps if we want to be able to discuss all, maybe again I will assign people, okay, to do one question, all right, for each. Maybe I will assign later. All right, I'll come up with a name. So whoever that I assign, all right, like usual, if you want me to share to the rest of the class, then you send me the photo. Okay, don't send me the PDF for the tutorial. Don't send me the PDF. I just need a Photoshop because I want to use my iPad. I want to paste it on my notebook. So if it is a PDF, I cannot do that. Okay, because if it is a PDF, I need to just project just one PDF file only. So I want to be able to, like just now, copy paste the photo, all right, on my worksheet here. Okay, so I need just in a photo, all right, image, not the PDF. So I'm going to assign people, all right, question 9 until 33. Okay, but even though, again, as I said, even though maybe those people they just do, okay, they just do one question only. It doesn't mean that they don't have to do the rest, okay? So you're just providing perhaps just one answer so that we can share to everyone. We can discuss to everyone. All right? But you need to also do all. You need to also try to do all. Okay. For those who would like to volunteer to answer questions, all right, you can just send me. You can let me know. All right? You can just send me and let me know your name and your what question, because I didn't save your name in my WhatsApp, in my phone. So you just send me your answer, all right? Or you can just tell me maybe beforehand. You can just tell me quickly that you want to volunteer to do what question, what, all right? And then you tell me so that when I come up with a list of names, then maybe I can just exclude your name and exclude that number as well. Okay, so if you think that you would like to volunteer one of the question from question 9, I think I already got somebody volunteer just now, question 9. Okay, so I'm going to hold on that question 9 for next week. Okay, so somebody already volunteered for question 9, so maybe after this 10 to 33. Okay, so if you would like to volunteer to answer, all right, if you would like to volunteer to answer, then you just let me know quickly, all right? So maybe I will come up with a list. Perhaps today is Wednesday. Maybe like by Friday. Okay, hopefully by Friday. Okay. All right. Any question? Any question for today's session? Any last minute question that you would like to ask? Anybody? Okay. Is it understood? Whatever that we discussed today, can you all follow? Is everybody okay? Yeah.
Yes, madam.
Okay. All right. So if you don't have questions, then we'll see you next Monday then. Okay, we can end the session now. We will meet again, all right, in Webex next Monday. And have a good weekend, all right, and stay safe, everyone. All right.